All right, so we're trying to validate our resources, our references to make sure we know what we're looking at is credible. We're going to use some basic common sense. And the next slide here gives us just kind of a quick, nice overview to know what's reliable and unreliable when it comes to websites. So read through them. I don't want to read all this to you guys. You can take a minute and read it yourself. But we do really want to look at this stuff and really try to figure out, who do we trust when it comes to presenting us with scientific information. Now, something I did want to highlight, if you look at, is this information authored by an expert in the field? Absolutely. I would think somebody who has 20 years of experience is going to be far more knowledgeable than somebody who doesn't even work in that field. So this does come into create a challenge at times when we're discussing issues or scientific information and you have two people that appear to have similar backgrounds disagreeing. Who do you trust? So take, for example, the medical field. I'm not, please don't think I'm trying to dish on or trash or beat up or whatever anybody who's in the medical field. They have gone through a lot of hard work to get to where they're at. But you think about the medical field, and there's so many sub-disciplines within it. I go to a general practitioner, but he then refers me over to specialists if I need help. So if somebody goes in and they have cancer, they're going to refer you over to an oncologist. Somebody has pulmonary issues or heart issues, refers you over to a cardiologist. Would you trust your cardiologist to tell you what to do with your cancer treatment? Probably not. They are a medical doctor, but I would rely on the oncologist, the person who specializes in cancer, to tell me what to do with my treatments. Just like if I have a heart problem, I'm not going to an oncologist to say, what do you think I should do about my heart issue? So within the medical field, there are so many different small subspecialty areas. That's when we want to learn and make sure we're trusting the specialist in those areas. So again, you get two doctors disagreeing. Who has the better background and experience in that particular field? That's the person I'm going to go with, not the other person who maybe had one semester in that during medical school, or maybe when they do the rotations. Oh, I spent 2 weeks covering infectious diseases as I was doing my ophthalmology or optometry degree. Well, so you spent 2 weeks on disease? Good, you know a little bit, but I'm going to trust an infectious disease doctor over an ophthalmologist any day when it comes to a disease, a virus, or something like that. Okay, so look through it. Make sure you get a feel for what are the reliable sources, what are the unreliable sources. We want to make sure we're trusting the source because it has valid information. So, all right, now when we do our research and we collect data and we get this information, we need to present it. And often graphs are used. We often use graphs to give us a visual summary, move that over here, to give us a visual summary of the results. So that's the idea behind graphing. Let's make it look pretty. Let's make it look fun. Let's make it look easier to interpret, especially if you don't have a strong background in the science. All right, so a graph is just simply a visual representation of the data. Now, on graphs, you have an x-axis, what is known as a horizontal axis, and this is where the information for the independent variable will go. And then you have a Y or vertical axis, and this is where the information where the dependent variable will go. The data you collected for the independent and dependent go on specific axes of the graph. So drawing it out, just keeping it real simple. Looks like a big L. Here is your x-axis. Here is your y-axis. That's it. Data points down here are where the independent variable data points go, and then data points on this side are where the dependent variables will go. All right, so when you plot a graph, we have to make sure we plot it correctly so we know what the data says. Otherwise, your graph is completely twisted and tilted and basically flipped on the side, and people are scratching their heads going, something's not right with the representation of the data. So, all right, so when we're graphing and we're looking at results, we want to look at what is known as statistical significance. All right. Oh, make sure I spell this right. There we go. Sorry. Statistical significance. This is when your results are unlikely due to chance when you have statistical significance. You get these results because it is factual, it is accurate versus just pure random chance. That's when it's statistically significant. So you'll see that in a good scientific study, it'll say statistically significant to, and it gives you a number. Now, don't expect 100% statistical significance. The smaller the chance factor, the more likely you're going to be accurate with your results. So we always look for this very, 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 very small chance factor associated with our research. We want strong, large statistical significance when we're doing this research and presenting our data. Right? So here's an example of data being presented. So 3 different groups for treatments. There's your independent variable. Somebody was given a placebo. Somebody was given a low dose of whatever this might be, vaccine, etc., and then a high dose of this treatment. So your independent variables, what changed was how much of a treatment they got. 0 treatment for placebo, little bit of treatment, high amount of treatment. And then the average recovery time is recorded. So that's your dependent variable. How long did it take the person to recover from whatever this is? Illness, injury, etc. And here are the results graphed. So whoever got the placebo, it took them on average about 60 days to recover. Let's say it is from an illness. People who got the low treatment dose or low dose of the treatment, about 50 days recovery. And people who got the high dose of the treatment took about 20 days of recovery. So what it shows us, what we can interpret from this data, is a high dose of this treatment shortens the recovery time for whatever this is, disease or this illness or whatever people are suffering from. Now, the bar here, this bar, and this bar, is what they call the margin of error, saying, okay, it could have actually been lower. So maybe it was down around 50 days if you had the placebo for what it really took to recover, or it might have been up to about, I don't know, I'd say that's about 76 77 days. That's kind of the range of error in measuring. Same thing here. You can see where the bar stretches, and then the same thing here. Now, what we can do is look at all three of these and still draw a very, very solid conclusion that the high dose of this treatment is significantly better and it shortens recovery time. Where you get into kind of a gray area is when two of these columns are pretty close in height and then their error bar is close, because then you go, well, is there really a big difference between this one and this one? I mean, this I would say there is enough difference, but sometimes the bars are closer. And then you look at it and say, well, maybe the results aren't as solid as we'd like. Well, let's run the experiment again. Let's do it with another sample size of however many patients. So we want to be comfortable looking at that data and again figuring out, is this data reliable? So all right, so to wrap all this up, why do we care about this? Why is this important? Because we make decisions based on this information. So here's 5 questions to ask when you're evaluating a scientific claim. Guys ever hear of cupping? Olympic athletes, was big and huge in the Olympics a couple years ago, especially in the swimmers. They're all coming out. They've all been cupped. Is there science behind it? So start with, does it seem logical? There's a thing known as Occam's razor or parsimony. Simplest explanation is often the most accurate. Does this claim seem logical? Maybe you say, yeah, I think it makes sense. Don't agree because it matches what you want to believe. Put away belief, look at logic. Sometimes they go together, but sometimes we have to separate them out. Is the source credible? We talked about how we determine credibility, validity, reliability. Let's look at that. Are there scientific studies to back up this claim? What do we have out there? Show me the data. Show me the studies. How recent are the studies? Oh, a study from 1914. Okay, probably not going to really rely on that one. Do we have anything recent within the last couple of years? Has more validity to it, more likelihood that it is accurate and valid. Are the experiments well designed? I want to see the experimental method. What did they do? What was their sample size? How did they design the experiment? Show me if this is truly accurate. Then I may say, okay, I agree with this claim. Even if it goes against my belief, the science may prove this claim is credible. And then does the data match? Again, does that data match what they're claiming it to do? If they're talking about cupping or I'm selling you this product or I'm trying to get people to buy this, excuse me, this or that, go through this. Go through these 5 questions and see, is it worth it? Why? Why do I want you guys to be able to do this and be aware of this? We are all consumers. How much money are you spending on products? That's why I want you to be able to do this. Does this product work? Oh, rub on this cream and it gets rid of wrinkles. Really? The cream actually can penetrate through all the dead layers of skin to get down to the layer of skin where the wrinkle's at? Walk through these 5 questions. Take this pill, it'll give you energy. You'll be back to what you felt like when you were in your teens and 20s. Really? Walk through these 5 questions. So the idea is we are constantly making decisions about our health, the environment, about public policy. I'm just going to put a huge etc. here. This is why I want you guys to be familiar with this.